Okay, let's start talking trash. Big topic. So as we talked about in class, we took notes on landfills, and there's just another picture of what a landfill really looks like in schematic form. You can see that we have our leachate lines where we're pumping that stuff back out, putting that into sewage treatment. We also have our monitoring wells here, and our gas recovery system collecting that important gas methane. So I just wanted to show you some pictures of real landfills. Here's a landfill getting created. You can see that it's probably got some good clay soils there. And then this is being lined. And then you can see these are the leachate lines that are being put in to collect the leachate. And then we start filling it up, and they put the garbage in it, and they put some dirt on top, and they put some more garbage in, and they keep on smashing it down, right, to keep all that air out. And eventually, what used to be a hole now is a large hill. So this used to be a hole right here, and they just build that up full of garbage, and then they can plant on top of that. It looks like on the very top here, now they have a composting facility. They might still be adding to it. I don't think so. I think this is a done landfill. And then you can reclaim the use of this area. You know, you can make a park out of it. You could, I don't know if you want to put houses on it, but you can reclaim that area. This is actually the landfill in Chapel Hill. It's done. We don't actually have a landfill in Chapel Hill anymore. It's topped out. That's the cap. They planted, unfortunately, non-native grasses on top instead of native grasses. But it is all of our garbage now actually gets shipped 120 miles away. It comes to this as a transfer station. They load it up in trucks, and then they take it off, take it away. But I was fortunate to tour this facility a few years back with some students. And we had a personal tour, and right here is the gas collection facility. So all of the methane gas comes up in through these pipes right here, and then this machinery here burns the methane and generates electricity by having them turn turbines. So pretty cool stuff. So what's in this garbage? There's a lot of stuff in here. I want us to think about the components of garbage. I've got it divided up here into all these different categories. That blue category, what do you think by mass, what is the largest component of trash? Now, we're talking about municipal trash, municipal solid waste, which means the waste that's collected at the street, not commercial waste. But what do you think that blue category is? Looks like about 30% of all trash. What do you think that is? Make a guess. That's paper. So paper is a very large section of municipal trash, municipal solid waste. And the next one, what do you think? Yard trimmings. Yard trimmings. So those are branches, grass clippings. This is the stuff that actually goes to the landfill. Most landfills do not actually put those yard clippings in the waste in the landfill anymore. They do something else with them. The next one, what do you think it is? The green one. Food waste. That's actually a very large component of food waste. That does go into the landfill most of the time. What about the next one? Purple. There's your plastic. That's the plastic. And then the other ones, we have metals, glass, wood waste, and then all sorts of different things, electronic waste. Rubber, leather, textiles, things like that. This is just another way of breaking it down. Instead of breaking it down by what it actually is, you can talk about its use. So if you look at that, one of the largest categories is containers and packaging. And then you throw into food and yard waste also, and then durable goods and non-durable goods. Non-durable goods, or I should say durable goods, are things that are designed to be used for 3 years or more. If it's a non-durable good, is more like a disposable product. But some of the things that we make that last just a couple of years are not considered durable goods. So it's just something to think about. So how do we got landfills, we got problems. Landfills are problems because we're running out of space. It's also just a waste of resources. And landfills have problems too. As we said, methane production and all those things. So what we do is to solve the problem isn't to build more landfills. It's to be smarter, to reduce, reuse, recycle in that order, and compost, of course. So what do these things mean? What does reduce mean? Well, it's pretty simple. Reduce means to don't use as much stuff. Give me an example of something that maybe you just don't have to use as much of. Throw it in that question answer. The next one is reuse. So reuse just means instead of throwing something out, right, use it more than once. Sometimes you can use the same thing more than once. My mother used to wash paper towels, but you could also take a tub from yogurt and you can use it for nails. I mean, reuse has a lot of good ideas, suggestions. Or you could buy used, and that you're starting with something used already, right? So let's talk about recycling, because recycling, I don't know if I told you this in class, but recycling is generally not part of the solution. I'll tell you why. So true recycling is called closed loop recycling. And closed loop recycling reduces the demand for raw resources, which means you don't have all of that extraction and processing and transportation costs associated with it. And if it's recycling, you don't have the waste with it as well. So that's all great stuff. And so the perfect example of closed loop recycling is aluminum cans. So here we have aluminum can, you have iron ore, or aluminum ore being mined, processed, smelted into these nuggets. Then it gets made into a can, but when it gets thrown out, recycled, it can quickly just be made into those nuggets again and then made into a new can. And you can do that over and over and over. You literally can do it millions of times because aluminum is an element. It can't change. And so that is true recycling. Aluminum cans, absolutely a great thing. It takes a fraction of the amount of energy and none of the resources to extract this. You extract it once, then you can just recycle it. So we should be recycling all of our aluminum cans. Unfortunately, a lot of aluminum cans don't get recycled. But we can recycle anything that's made out of aluminum. This is an example of how windows are recycled. So you build a house, you put the windows in. At some point, that house is going to be demolished. Well, those windows should be designed to make it easy for them to be torn up and made into new windows again. That's closed loop recycling. If you start with a window, you recycle it and make it into a new window. You start with a can, you smelt it down, you make it into a can again. Then you don't need those resources over. That's recycling. Got it? Okay. Because the kind of recycling most of us think about is what's called open loop recycling. So I know we all say, well, I use plastic bottles, but I recycle them. You can't recycle a plastic bottle. Period. No matter what you've been told, there's no such thing as recycling plastic. And this is why. So here's an example of recycling bottles. Now, I know you might not be able to see that, but we start over here with petrochemical feedstock. That means oil, because plastics are made out of oil. So that's mined in the ocean or drilled for. Then you make this plastic bottle, right? And then you use it. And most plastic bottles go into the ocean or they go into the landfill. Most don't get recycled. That's just the fact of the matter is. So people say they recycle them, but most don't get recycled. But let's follow the ones that do get recycled. So you can't make a new plastic bottle with an old plastic bottle. That's the problem. So what can you do with it? Well, they generally shred it up and they make plastic fibers. And then they add a little bit more petroleum feedstock usually. But you can make something with that. You can make maybe a pen, or you could make filling for a jacket, or maybe you can make carpet, or maybe a picnic table. And these are all great uses. Problem is, eventually you're going to throw that object away. And so it's not recycling. It's reusing once, which is great. But it also doesn't reduce the supply, doesn't reduce the demand for new bottles, for the material for new bottles, because you're not making new bottles anymore. So when you recycle a bottle, you have to make a new bottle over again. And so that is called open loop recycling. And perhaps it's good when you're making a picnic table or something very durable that you're not going to throw away. But it doesn't reduce the demand for resources for the bottle anyway. So keep that in mind. Recycling, I think it's a great way of getting people interested in doing something, but then you got to quickly tell people, you should probably just not do it. And most plastics are not recyclable. There's very few plastics that actually are recyclable. Bottles and some tubs. Any other kind of plastic in our area is not recyclable. So the other thing that I get really excited about is composting. So composting, you can compost anything that's natural, anything biodegradable, because composting is basically biodegrading partially that material and then putting it in the soil or putting it someplace so that it can add nutrients to the soil, right? And when it decomposes all the way, it does create CO2 because that's from the sugars in the natural product that was trapped. The CO2 from photosynthesis came down and was trapped in that material, and now when it's decomposed, CO2 goes back. It's a cycle. We know that. But CO2 is much better than methane. CO2 is a greenhouse gas, but methane also is a greenhouse gas, but it's, depending on how you do the math, maybe 100 times more heat trapping than carbon dioxide. So we got to keep compostable materials out of the landfill, not just because it fills the landfill and that we can make great compost out of it, but we don't want to create that methane. So what do? We make some good compost, and we've got a great compost facility here in Orange County. So how do you compost? This is a commercial composting facility. They can change compost. It looks like that after about 6 weeks, and then they let it steep for a while. It takes about 6 months to a year to actually get it out the door. But this is a special machine that just drives over these piles and aerates them, turns the piles over once every 2 or 3 days. So that's an industrial composting. You can also compost at home. I've got a compost bin at my house. I put all my dried leaves and stuff there. I shred paper all the time and stuff, tax documents, things like that. I stick that in there because that'll decompose. All my food waste goes in there. So you can compost at home. You can also have worms. Now in my classroom, I have a worm bin. This worm bin right there. And the worms will eat the food waste and create magic. It's called black gold. It's great for the garden. So that's called vermiculture, or composting with worms. You can compost anything that's natural because it's natural way, nature's way of recycling. Here's you can make. We bought this worm composter, but you can actually make one. We got some of those in my classroom too. So this is a picture of my son. Is actually on the left. My son Isaac. He traveled with me to Ecuador with students about 5 or 6 years ago. And this is the job that he got chosen for, was to clean out the composting toilets. So we have composting toilets because we're up in a rainforest. There was no running water. Plus, they didn't want to pollute the area. Plus, there's a permaculture institute. And so what they did was the human waste gets composted. And after a couple years, it just looks like mulch. And so they had to take it down. And we were also planting some papaya trees. So we can compost human waste. And here are some papaya trees that we were growing, and we're spreading this human waste. And it's not human waste at that point, it's compost. And the kids eventually took their gloves off and they're like, it's compost, we're just putting it in there. It's been broken down enough where there's no pathogens or anything in them. So let's take a look again at this picture. We have all of these kinds of waste, and what we're going to do next is we're going to start looking at, well, what can we do with this instead of putting in a landfill? How much is natural and compostable? How much of this can recycle? And then whatever is left over, well, what can we do to get rid of that too? Because the idea is, got to get rid of all of this. None of this needs to happen anymore. So there you have it. And I can't wait to see you in class.